First up is Dr. Ravi KOPPARAPU. He's a planetary science from NASA Goddard Space Flight Center and lead scientist of the Sellers Exoplanet Environment Collaboration, SEEC, at NASA Goddard. His research interests are extrasolar planet habitability, atmosphere modeling and characterization, and identifying technosignatures. In 2020, he was the recipient of the NASA Exceptional Scientific Achievement Medal. So with that, let me turn it now over to you, Ravi, if you'll begin, please.
All right. Thank you, Ed. I'd like to thank the organizers, Nijo, Ed, and Vincent, and also Carmela for organizing this session. And I hope this would be a stimulating one. As Ed said, my name is Ravi KOPPARAPU. I'm a planetary scientist at NASA Goddard. I was trained as a physicist, and my primary research interest in studying atmospheres of planets. This is my first time attending an aeronautics conference, and I thank you all for taking the time to attend this session. So my primary goal in this talk is to highlight the need for scientifically studying the unidentified aerial phenomena, or the UAP. Science is how we make progress in understanding the world around us, and it is unbiased. Even null results are illuminating, even if we find something is not there. So my hope is that after this session, there will be momentum towards a scientific study of UAP. Next slide, please. Thank you. So before I move on, I want to actually define what an UAP means. And because I will be using this term several times, it would be good to say what it is. There seems to be no universal definition that I know of, and there are certainly other more expanded ones to define the UAP. I'll be using this definition in this talk to broadly cover the class of phenomena. So what it would be is that it's a class of phenomena observed within the Earth's atmosphere that cannot immediately be recognized as known physical phenomena or objects. We can discuss in the Q&A session regarding the merits and shortcomings of this definition if needed or if someone asks. Next slide, please. So to begin with, at the end of June, the Office of the Director of National Intelligence released a preliminary assessment on UAP for Congressional Intelligence and Armed Services Committees after a UAP task force was created last year by the Pentagon. This task force was created because of reports about UAP posing flight safety issues for US Navy personnel. You may or may not have heard about these reports that first started appearing back in 2017, when major newspapers started publishing accounts from our Navy pilots encountering some UAP. And Lieutenant Ryan Graves, who will be talking shortly, may have more to say on this. So this talk will have some reference to the report, and also related to some of the phenomena from the historic viewpoint from the last several decades. Next slide, please. All right, so the report here had some summary points that I will very briefly go through. What I found to be very interesting about the report itself is that the language and the tone of the report is consistent with how we in sciences write our results in scientific publications. It was agnostic, just presenting what is known regarding the observed phenomena or the data. There was no speculation, and there are some highlights. And I've tried to highlight some of the things that I found to be interesting in the report. The first one was that most UAP they seem to be physical objects recorded by multiple sensors. The report did not make clear what kind of sensors they had and what are those readings. Some may be sensor anomalies, and what kind of those anomalies are they? It would be really good and useful to weed out the false positives so that we know there is something, a real object, or it's just a reading mismeasurement by the instrument that they're working on. The report also mentions that there are probably multiple type of the UAP, which means that there is not probably a not single explanation based on the appearances and the behaviors that they have observed. So it may not be possible to have one single explanation to explain all the class of phenomena of UAP. And that's why I made the definition. I tried to cover that definition with this, that there may not be a single one explanation that we can come up with based on what we know. Next slide, please. So there are some patterns that may be emerging according to the report, and some of them are a bit interesting. They seem to have, at least the ones I highlighted over here, in some incidents, some UAP appear to show considerable speed, maneuver abruptly, no apparent clear means of propulsion, and in some cases have been known to have radio frequency emissions as well. These seem to be these kind of observations, or at least the characteristics, seem to have been also observed in earlier investigations of UAP back in the 50s and 60s when it was scientifically studied. There was one aspect that they mentioned in this report, which is called the signature management. I tried really hard to understand what it would be, what it means, and I think it probably is. There is a signature, and maybe there is a certain type of signature modifications that UAP may be exhibiting, which is only my guess at this point, beyond anything what they have written in this report. So we have to. I'll come back to these observed characteristics from this report because it will be useful in comparing with historical studies of UAP. Can we go to the next slide, please? The report concludes suggesting that we need to collect more data, and even looking in the historical radar data to understand better the patterns that we see for this UAP. The critical point here, I want everyone to remember that the critical point here is the data collection. We make advances in sciences by collecting the data and sharing the data so that we can verify false positive, we can verify the validity and so on. And so additional data is needed to know and understand the nature of UAP. And I hope that this session would be a good first step towards in that direction. Could we go to the next slide, please? Can you hear me? Yeah. Oh, great. Thank you. So I mentioned briefly in my earlier slides that some UAPs seem to exhibit similar observed characteristics described in earlier investigations back in the 50s and 60s. This is a screenshot, or at least an image of a presentation made by Professor James McDonnell, an atmospheric scientist from University of Arizona. And he presented this at the AAAS meeting, the American Association for Advancements of Sciences, and to scientifically analyze some UAP cases written in the Condon report. And Professor McDonnell was a member of National Academy of Sciences and a well-known atmospheric scientist. And he had interest in this UAP phenomena. And he went through some of the cases and tried to analyze them in a very scientific, using the scientific methodology. In my opinion, this is one of the best scientifically studied or written document on UAP investigations. Coming from my science background, I feel that, and the way the report was written was more how a technical report, a publication, a scientific publication would be written. So I was able to connect a little bit more with it and try to go through the details that Professor McDonald went through in here. Slide 8, please. Next one. Thank you. So there were 4 cases mentioned in this report. One of them was the RB-47 aircraft case near the Gulf Coast area back in 1957. The AIAA, there was an AIA subcommittee that also had studied this and made a report of this back in 1971. Which was a bit inconclusive what went on in that particular case. There were some questions that were unanswered in this particular instance. The remaining 3 cases also, Professor James McDonald mentioned in the report, the Science in Default report, also exhibit, in all these 4 cases, exhibit similar behavior with what we have the report from the DNI mentions. And so there seemed to be some similarity in terms of the pattern and also the observed characteristics of at least the objects or the phenomena that we see in James McDonald's report and also in the DNI report that came out last month. Okay, can we go to the next slide? So there were some questions about what can we learn from these old cases and why not just focus on the new ones? And in particular, what can we learn from this particular document that I was showing about, the Science in Default document from James McDonald? Next slide, please. Well, so one of the first things that we can come up with is the scientific study of UAP is not new. And there was an open discussion among scientists about the nature, even if they are misidentified or not, and it was not stigmatized. So there was free thought process and exchange of ideas about what they are and how the data can be collected. Scientists like Carl Sagan and Professor McDonald, Alan Hynek, they organized conferences and talked about this topic openly. And this is a welcome opportunity. This is how we do in science conferences. This is how we share ideas in sciences. This is what the reason why we are here right now as a technological species, because we followed the scientific method. We shared ideas here, and that's how we progress. And if we want to understand the world around us, we need to have this kind of scientific approach to understand UAP or not. We may find there's nothing to them. We may find there is something to them, but at least the approach, the scientific methodology is what we need to do. The sharing the data is what we need to do. The document, Science in Default, is one of the, like I said, the best investigative report on this topic. And it uses the same scientific methods and the rigor and that we traditional scientists use. Even if a traditional scientist read this document, I have sent this document to some of my colleagues, and even if when they read it, the methodology seems to be fine. I mean, maybe there was some, lack of data available. It's all mostly eyewitness, but the methodology is similar. So, and the important thing here is that there was no exotic physics invoked while writing this document. The analysis was purely based on what the observed characteristics were by the respective pilots or anyone. So this is why I would say that there was a historical precedent for us to study this UAP in a scientific way, and we should do a similar thing even with the present cases as well. And the DNI report also says similar things, that we should study them by collecting the data. This is what we do. Next slide, please. So for the case study, just as an illustration to see how we can do a little bit of scientific analysis, I'm going to take some reported instances where some UAP seem to have descended from a high altitude to sea levels in a very rapid time. Now, I want to caution that this is by no means an analysis based on an observed or collected data. And And if we go to the next slide, I'll explain what are the assumptions that we want to yes. So the assumptions here are that, I'm assuming that these are not radar anomalies. If this observation is from the radar, I will also assume that the observation is accurate, and this observation is observed visually, which means that the height at which these things were observed and the way they were descended and the amount of time that has lapsed during this descent is consistent with what really happened, at least close to them. No data is available other than the media reports on this one, so please take it with a grain of salt. But the purpose of this exercise is to show that, when we have the data, we can use the known physical aspects that we learned and derive the characteristics of some characteristics of these UAP. Now, what are they? If you go to the next slide. Because the reports indicated that they have descended rapidly from several thousand feet to the sea level, we can estimate what could be the possible time of descent regarding these objects when they are falling under the influence of gravity in an environment with atmospheric drag force acting as a resistance. These are aerial phenomena, so we can assume different shapes and their drag coefficients. We can consider the end member cases for these drag coefficients, which means that we can assume a large drag coefficient and see how things work out, and the small drag coefficient and see how things work out in terms of how much time it would take for a normal object that we are familiar with these different shapes, and see how much time they would need to descend from height, whatever the height they were reported from. The reported heights may not also be accurate. I've heard that they may not be as high as they were reported in the papers, but you'll see shortly that it doesn't matter, even if they are at half the height of the reported heights in the papers. Next slide, please. All right, so this is just the couple of equations I used to calculate the free fall time velocity, and based on the terminal velocity of these objects and the drag coefficients. I assume some drag.
Ravi, I'm afraid you've frozen. Thank you.
I'm sorry, how many was that?
You froze for the last minute.
Oh,
so you may want to repeat what you were expecting to say.
Oh, sorry. Okay, my internet. All right. So I just wanted to say that I used free fall time velocity and terminal velocity expressions to derive how fast these objects descended, assuming some type of mass for these consistent with the commercial airlines or even fighter jets, and drag coefficients and the area of these objects. So can we go to the next slide, please? All right, so here it is. So if we assume some mass and range of masses and range of areas, I'm not going to stick to one single value of mass and areas. What I'm showing here on the x-axis is the amount of mass that you can consider for these objects, and the y-axis is the area of these objects. The colored, different colored curves, regions are the free fall time descents in seconds. So the bluest ones are the very short time scales, and the yellow and orange ones towards the left top are the long time scales. And so you can see the scales actually, the color scale here go on the color palette on the right, the vertical bar goes up to 60 seconds or so. And what I have made this plotted on this plot also is how much time would it take a commercial airline to free fall under the influence of gravity, assuming some drag, assuming this drag coefficient. And you can see where that lies in this region. It takes about a minute or so, more than a minute actually, assuming different kinds of drag coefficients. And if you go to the next slide, the reported time of descent for the objects that have been observed in this UAP, at least the ones reported in the newspapers, they're off the plot. They were a couple of seconds or even less. And so I can't even plot them on this plot. So If you go to the next slide, let's say we change the drag coefficient even a little bit to maximize or take the end member cases. Even then, you can see the blue colored areas are the shortest time descent times, and the orange and yellow ones are the longest ones. And the commercial airline free fall times is indicated by that oval on the plot. Again, these are at least a couple of minutes, but with the amount of drag coefficient that we know of. Okay, so these are again the time of descent, observed time of descent seem to have been fraction of a second or a couple of seconds. Again, off the plot of this curve. Can we go to the next slide, please? Okay, so how do we compare this with the descent time of the New Shepard Blue Origin spacecraft that was launched a couple of weeks ago? That if we look at the descent time from 60,000 feet in zero gravity to the difference of 60,000 feet from that height in zero gravity, it takes about 60 seconds roughly. So even,
2 minutes.
Yep, thank you. Can we go to the next slide? So, right, so the acceleration and thrust seem to be in several hundreds of Gs, and so they are enormous that we can consider. Again, I want to give a caveat here that these are all based on the published, reported in the media, and we do not have the data. It will be greatly help us in doing this analysis properly if we have the data available. Next slide, please. All right, so here is my conclusion once, and I want these to be the take-home points. Science progresses without stigma, right? So no single explanation for all UAP events. We should have the scientific analysis done on these, having the data available. We need multidisciplinary scientists, engineers, instrumentalists. This is an aerospace problem. Each expertise is very valuable. No single person is an expert in all of the things. So we need help from other disciplines as well. These are transient events. As an example, to observe the ones that I just talked about, to determine the altitude, we need radar observations that could provide the speed, altitude, and size of these objects. If not radar, we need a 3D projection of these ones. So we need some sort of imaging on this. Fast track cameras probably might be suited for these transient events. Telescopes, this is not an astronomical phenomenon. So telescopes are probably not relevant, but we'll discuss this later. This is the last point I would like to make. Every object must follow laws of thermodynamics. They must emit waste heat. Which part of the electromagnetic spectrum that the heat is emitted is a question. So longer wavelength observations are likely needed if we want to know the observed characteristics, some of the observed characteristics of this UAP. Thank you. I think I'll stop over here.
Right on time, Ravi. Thank you.
Thank you.
I also now will enter into our 5-minute question answer. So from the audience, please ask your questions to Ravi directly.
Can I address Kevin's question or comment in the chat?
Sure, Ravi, please.
Yes, Kevin, yes, you're right. That's why I mentioned the caveat that some of the reported heights for these descent are probably not accurate. So I actually did an analysis, even assuming they are at 28,000 feet, because we had a conversation, right? So it didn't matter. Even then, it would take 40 seconds or something, 45 seconds. To do the free fall. So you're right that they must be having that. I just can't explain this phenomena just by free fall, because the amount of thrust you would need to reach within a couple seconds from that height, even from your 28,000 feet. I just do not know if these readings are right, if these reports are correct, and if everything I've done is accurate.
Yeah, we found, as I'll mention this in my upcoming talk, but we found that as these things had to accelerate and then decelerate, and that the minimum acceleration is on the order of 5,000 times the acceleration of gravity. It's the only way you're going to get in the ballpark of what was observed.
Yep, that's right.
Thank you.
Yep, thank you.
Other questions for Ravi, please?
Hi, this is Christopher Plain from the debrief. Ravi, can you hear me?
Yes, I can. Thank you.
Okay. I see at the bottom of this slide, it says every object must follow laws of thermodynamics. Is your research also considering atmospheric phenomena, or maybe visual phenomena, something that may not be a physical object? And therefore, would that also be constricted to those laws?
So the laws of thermodynamics apply everywhere, right? So if it's an atmospheric phenomenon, if it's a physical object, it has to have waste heat. But if it is not, and if it's not an atmospheric phenomena, it must follow something else, some other, similar laws of thermodynamics. So it could be some an atmospheric phenomena that we could figure out if we have enough data available on that.
Okay, thank you.
Mm-hmm.
Ravi, I have a question for you. He is Rene Nardi. I'm from New Jersey. The question is, on your charts, you have considered the drag coefficients 2, 1, but have you considered 0 as a drag coefficient?
So the reason why I did not consider 0 is because the lowest drag coefficient I could justify was this airfoil one. And I
agree with you 100%. Your approach is 100% correct. However, what if drag is 0? What happens? I don't know how to get to 0, but we should start asking weird questions. For example, you raise a great point. Heat must be there. It's just a matter of wavelength that we are not collecting information about heat signature. Just think about that. What if drag is 0?
Yes. So can I quickly answer that question? If you go to
Please.
The next slide. The next slide. Yes. Look at what happens if drag coefficient is 0 in these equations. So CD is the drag coefficient. If it's 0, the terminal velocity becomes infinity, or the descent time, and the final descent time would be instantaneous. And so for me, I do not know how an object, if it is an object at all, as someone pointed out just now, it may be Christopher, I think, pointed out, it may be an atmospheric phenomena, or maybe anomalous reading in the instrument. If we assume that is an object, an actual object, I do not know how a physical object would have a 0 drag coefficient and have an instantaneous time of descent with a terminal velocity reaching infinity. That is not how I know how it works from these equations, at least. But I need to have a physical motivation, is what I'm saying, that to consider a drag coefficient 0.